Hello again, friends. So I spent the last couple hours just thinking about how to go about this lesson. This one being about math, as hopefully I give this a good title, and that's obvious. Haven't done the title yet, but So I've been thinking about how to do this because, what value would it be for me to just demo how plus works? I don't think there's anyone watching this video who does not know how plus works, and if you do, I recommend a prerequisite to this video. So what I figure is the best way to go about this lesson is just to build off of what we learned with type classes. And so as I mentioned in the last video, I decided not to go over numeric type classes just because there's like way more. And it would just overcomplicate or, put just too many things to learn in one lesson. And so those other classes, EQ, ORD, enum, you could argue are kind of mathematical in a way. They are logical in that, it is very common. You might think of doing is equal to, with the double equal sign as being sort of a mathematical function, but yeah, I decided it was kind of simple enough to think about in the last class for last lesson for talking about how type classes themselves work. And so with numbers, as we'll see in Haskell, there is quite a lot more there's like a lot more complexity in terms of the type classes, but as long as you understand what type classes are, how they work, and what they mean, it really doesn't add any complexity to you as a programmer. I've used a couple of these functions from even some of the more I would say down the line classes, and I haven't even thought about what class they are from. I really don't even need to think about what numeric class I'm using. I'm just more thinking about what am I actually trying to do? I'm trying to add two things together. I'm not thinking about the fact that, one might be a float and one might be an integer. I am just simply thinking about the fact that I have to add two things together. And so Haskell makes that easy through the class system, where I don't have to think about what I'm doing with with an int or integer or any of that. And so, as you can see, this is all of the instances of the num type class, and there is quite a lot here. You'll see cint, and that's like literally the C language int. Haskell has a foreign function interface with C and a couple of other languages such as JavaScript, Python as well. You could really build a FFI for anything, or a foreign function interface for anything, but yeah. So just to start, here are all the actual core types that we're talking about. So we've been using int, which is, I think it's down. Yeah, I remember seeing it. It's more down here. So this is the one we're used to seeing, and I was kind of eliminating the type class just to say we're adding an int with an int to get another int. Of course, the same with subtraction and multiplication, negate. There's a ton of functions that we could talk about, but again, they're all pretty straightforward. The one I will talk about is there are a couple functions. Again, I'm not going to talk about them in depth, but from integer, for example, just converts from an integer to an int. Well, at least in this case. So from integer, more generally, is converting to a num a, is how this reads. So why that reads like that is because all of these a's correspond to this A. And so I'm just on Hoogle here, as you can, I'm on Hackage, which I found through Hoogle, so I could search Hoogle and go num type class, class num, and it takes me right back to here. So yeah, pretty. I think it's all pretty straightforward there. I do recommend you, experiment with this. But actually, another thing I will add too. I didn't plan on adding this, but I think it's especially important and relevant for mathematics is infix operators. So I read this as infix left precedence of 6. And so let me think. So just I honestly forgot which way it is, but just seeing that multiplication is a higher precedence than addition, meaning I can infer that the higher the precedence given here, the earlier that is going to be operated on. And what that means is if I have a, let's say we do 1 plus 3 times 2, unfortunately is seen so many times on Twitter and guessed upon wrongly. This is going to be a 7. That's pretty sweet. I don't think that's actually the case in Python. I've been doing some Python recently, and I think I actually have to put this in brackets. So that's a little annoying. And don't at me, please, if I am wrong on that. I probably just did something stupid. Silly me. But yeah, that the only real special thing here is that's non-intuitive is this idea of from integer, and there's a couple other ones. From integral, I think, is another one. Is that a thing? Am I remembering this correctly? So from integral? Yes. So this is the one that I was thinking of when we were looking at from integer. And so what this is actually starting to get down into the down the line type classes. And so we can see our num type here and integral here. So integral we'll get to in a second. All you need to know for now is that it is a smaller subset of the num types, or as a class it has a smaller set of the numerical types, I should say. And so as we can read from the type signature, now that we understand classes, this is I guess a little bit more complicated of a type signature, so I will explain it out. So I start by reading this, and I see that it's an A to B. Okay, what is an A to B? A corresponds to this integral, so A must be of the class integral, and B must be of the type num. And so this is kind of cool because we're saying that the return type must be of a certain type class, not a specific type. And so we're starting to kind of overload our functions here. And this makes a lot of sense because so why we would use this function is that, as we will see with a little bit more with integral, and the types that are an instance of integral, you could logically see how you can do division on them, but of course computers cannot read minds. We have to tell computers how to do division between a float and an int. So if we have 7 divided by 3.4, that's not going to work up front. What we're going to need to do is we're going to need to say from integral of this a, so 7 being our a. Let me think. I forget what the function is at the moment. Let me think if this is going to work. Well, I could force this to be an int. So I'm labeling it to be an int, and then I'm going to divide it by 3.4. And yes, this is not going to work. Hallelujah, we failed. And the reason it's not going to work, I think this would actually work too if I said that, because if I look at the type of 7, it's a type num. If I look at the type, If I tell it that the type of 7 is an int, then, you know, it doesn't know how to work with it. Here, it is assuming, since I've only told it that I want to use the literal 7, it doesn't know what exactly that is. And so it's going to keep it as a num p, a p constrained to be num, and which doesn't really give it any constraints in terms of numeric, stuff at all. But here, where I have constrained it to be an int, I need to bring it back from being an integral, or being from an integral in specific int, and then it will work. So that's only really gotcha. So now just kind of going through all the other classes here. So this is all just in Prelude in the base package, which is just standard in every single project that you would have. It's implicitly imported. As you might recall, I had the no implicit prelude statement, I'll call it, and that just got rid of this prelude so I could mess around. But this would all be implicitly available. Anything here I could ask the type of right now in my terminal, and I'd be good. So the second one here, so as you can see, real is a superclass of num, which we just talked about, and ord from the last lesson on just generic types. So ord for ordering. Again, just that guy. And so has this method to rational. I've never actually used that. I'm not sure where I'd want to use that. I guess that's really it. Integral. And so so integral, I believe, if I do recall, that it just has a bunch of sort of integer division. Yes, exactly. Supporting integer division. We can see rem for remainder. So if I do rem 3 and 7, and then 7, rem 7, 3, I get, of course, a remainder 3. I don't know why my brain's not working. I'm sure you can understand. You can understand why that is, but for 7 doesn't go into 3 at all. That's what it is. My brain was just like, 3 goes into 7 twice, has 1 remainder. Makes sense. And these do similar things. Again, I recommend just playing around with them. And I forget which one. One of these is extremely useful. So you know what? I'm just gonna play around with them. And quotient. What is quotient again? Right. But there was one. I think I used div mod a bunch, and it's really helpful. I think I just used it a bunch for when I was doing practice questions, and hackering questions a lot more. But what this is saying, this gives me back how many times 3 went into 7, as well as the remainder. And so we also haven't really talked too much about tuples. That's kind of honestly by accident. And the reason for that is that a tuple in Haskell is really just the same as a kind that we could make up with, for example, either. It will, no, that's a bad example. Constructor AB, constructor AB. A tuple is effectively this, and that it just holds 2 values. So I guess that's partly why we haven't talked about it too much. Yeah. But, so in this case then, we could say first, so evaluate the div mod 7.3 and then get the first value, which is a 2. We We could also get the second by doing like that and get that. But then again, if we're doing first or second, we might as well just do, div or mod. This is just combining the two. So, or maybe we do want both, and that's how we extract them. So, So I guess then, so we were on integral. Just have a little chart here with me. Have we gotten to fractional? No, we have not. So this is where we're dealing with non-real numbers, or like, I think I just messed up my terms there, but fractional and decimal, fractions, of course, and so this allows us to work with a double, work with a float, and there's a bunch more here, but these are you don't really have to pay attention to these. You can write any I don't even use any of these types. You could, although complex, actually, that does make a little bit of sense. Ratio does make a little bit of sense. And so, if we do, I gotta say, I also haven't, I don't know if I've ever actually had to create a fraction here, but I guess we do see this. Would this work? Let's try it out. Ah, that does work. Cool, yeah, so that actually does give us a reciprocal there. So that's fractional. Again, just recommend, being aware of all the different functions that you have available. Just trying to get through all the different type classes here. We have floating. We still have actually quite a few to go through. So I'm taking my sweet time. I think, have we gone through integral? I just got to make sure. Yes, we have. Fractional, we just did. Floating. So this is superclass of fractional, and this is more of your, scientific functions that you see on a scientific calculator. And, yeah. So, although this is saying that it has to be for a double or a float, I could even do this, I bet you, with, let's say, square root of 7, which you might think of as being an int, but that's only if I was to tell it that it is an int. Otherwise, it's just simply a num p, or p that is constrained only to being a num, but nothing further, unless we force it to be. So, and then that leaves just two last ones here. Real frac, float, well, real frac. And this is, your round type functions. I don't think I've ever used truncate, proper fraction. I just used this a second ago. What does this do again? I don't know why I want to use that. Again, just they're all simply available, and I can see when you'd want to use floor. Although I'm only thinking about times when I've used that in Python, and I don't know when you would want to use that, given that you have div mod and such. Okay, and the last one, which really, again, I'm just going to it for the sake of awareness and listing them off, is real float. And I haven't even ever used this before, but it does exist, and more kind of not super oftenly used functions. But yeah, if you have a use for them, I'm sure go ahead. But yeah, I have nothing really to add here. So anyways, but I will say there is, actually, I gotta go back to it. I closed it. So there is a wiki for Haskell. If you are looking to do any, no, that's not it. Don't want to close that. Here we are. So if you do want to look at more in-depth mathematics, obviously we're talking about very simple mathematics here. There is a ton of different functions that exist in Haskell. And I will say, I think this is definitely going to be different and weird for people who are new to Haskell. So if we look at this one here. So you might think, holy frig, this is not maintained. And no, actually, it is working. I believe there's another one that is not hasn't been touched since 2019 that I pulled up, and it's building. There's no problems with it, and that seems very weird for people coming from other languages. I imagine most people are coming from other languages, because if you see that in other languages, it just means that hasn't been maintained or kept up in the last little while. But with Haskell, it is very easy to get to a point where you do not need to maintain your code. And that is a huge flex. Like it is absolutely a thing. I don't know how I can mathematically prove it to you at this moment, but it is awesome. So especially something like math, that is definitely the case. Math is not changing. It shouldn't need to be maintained. If something needs to be maintained, it's simply a matter of either a lower level piece might have changed, and you need to upgrade to that new library, or you simply have bugs in your code, and that's what you're maintaining. So yeah, don't need to do that here. Also too, I just found this, and this is really cool. I'm definitely gonna mess around with this. This is just some bindings in Haskell to matplotlib. I'm sure you all know. Well, maybe you're familiar with matplotlib. And so it's a Python library, and so you can instead do your matplotlib through through Haskell. So I thought that was really cool, and just thought I'd kind of highlight that. But yeah, so that's really all there is to say about math and Haskell. Not all there is to say, but all that I should say. So yeah, thank you again for watching. Please let me know if you have any questions, especially if you would like for me to elaborate on anything further. This is definitely a case of I'm trying to give you a very, 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 very quick synopsis of a very complicated thing, and so I can't really do that at the same time that I am diving into derivatives in Haskell. So if you would like to see something like that, even matplotlib, this is definitely something I want to mess around with. Please do request. And thank you so much.